Hello, welcome again. We are covering the subject compressible fluid flow for civil services mains, IFS and GATE aerospace exam. We have covered the topic variation of properties along the nozzle with area ratio. So now we'll solve the numerical based on that topic, and that numerical or question is: consider the isentropic subsonic supersonic flow through a convergent divergent nozzle. The reservoir pressure and temperature are 10 atmosphere and 300 Kelvin respectively. There are two locations in the nozzle where A by A star is 6, one in the convergent section and other in the divergent section. At each location, calculate M, P, T and U. So first of all, we will take the convergent part. So this is your nozzle. This is your nozzle that we have discussed in the last article. This is convergent part, this is divergent part. First we are taking convergent part. Suppose A by A star is this quantity. A by A star is your 6 here. Then from the isentropic table, according to A by A star is equal to 6, we can see the various property. So here, this is your isentropic table, and first, as we are considering uh, convergent part, so there will be subsonic flow. So corresponding to 6 area ratio, this is the area ratio. Here it is 7.2 because it is 0.7262 into 10 power 1 means 7.2, and this is your 5.8 because 0.5822 into 10 power 1 is your 5.8. So 6 lies in between here. So we will take uh, the will use interpolation and we'll find out Mach number. So it is approximately between point 0.1 and 0.08, or by interpolation we can find out this. So this will be a 0.097 because 0.58, because 6 is we are very close to 5.8. So this value according to 5.8, this value is 1.1. Okay. And for A by A star is equal to 6, it will be approximately 0.097, or we can use interpolation. And now corresponding pressure ratio and temperature ratio can also be noted from this table. Okay. So this is A by A star corresponding to 6 in the subsonic part is 0.097, M is 0.097, P naught by P is 1.006, and T naught by T is 1.006. So here we can also note this according to, suppose we take according to 5.8, then it is 1.002, and this is your 1.005 density ratio, and pressure ratio is 1.007, and these are very close. Here plus 0.1 means point, it represents point 1.007, this is 1.1, this is 1.005, this is 1.001, this is 5.8001. So T naught by T is at 1.002, T naught by P is 1.06, M is 0.097. So this is the Mach number at location where the area ratio is this. And now we have P by P naught or P naught by P, and we also have P naught, that is 10 atmosphere, so we can calculate pressure at this location. So that is 1.006 into raised power minus 1, or we can into 10, or we can say 10 by 1.006, so that will be 9.94 atmosphere. Similarly, T is T by T naught into T naught. T naught is your 300. T by T naught is 1.002 therefore minus 1. So that is 299.4 Kelvin. Okay. Similarly, sonic velocity, because we need to find out A, M, T, T, A, so P and T are there, and is 0.097, and sonic velocity is root gamma RT. So that T is your 299.4, gamma is 1.4, R is 287, so that is 346.8 meter per second. And velocity is your mass into, sorry, Mach number into sonic velocity. So that is 0.097, and sonic velocity is 346.8, so that is 33.6 meter per second. And now in divergence section, so this is your convergence section, and in divergence section A by A star is your 6, because this is given. And now this is the value corresponding to subsonic flow. Here Mach number is less than 1. Okay, now we'll see the corresponding value according to supersonic flow. So this is your supersonic 0.6, sorry, subsonic 0.6. We'll move we have to put 6. This is 1.439, so we have to move, this is 2.6. Now this is your 6, here it is 5 approximately 6, 5.9, and it is between 5.9 and 6.1. So we'll take the Mach number corresponding there. So corresponding to 5.9, the Mach number is 3.3, and corresponding to 6.1, it is 3.4. So we again will use interpolation, so it will be 3.368 according to A by A star 6. And the stagnation pressure to static pressure, stagnation temperature to static temperature. So these value are also can also be noted down from this. For 6 we can, for more accuracy we can take interpolation. So that is your, this is your pressure ratio. So that is approximately 63.13, because here this is these are the values, 61.52, this is 66.12, and temperature ratio is, so density ratio, this is temperature ratio is 3.244, and this is 3.312. So using interpolation we can find out the exact values. So P by P naught is your P naught by P is your 63.13, and P naught by T is your 3.269. So we can find out pressure, because this pressure ratio is known and P naught is known, so that is P naught by 63.13, and we can find out T also, that is T naught by 3.269, that is 91.77. And again same way the sonic velocity at this location, it is root gamma RT, 1.4287, 91.77, that is 192 meter per second. And Mach number is 3.368, so U is your 646.7 meter per second. So these are the we are getting different velocity in convergence section and divergence section, and in convergence section it is 33.6 for the same area ratio, and in divergence section